So this video is going to be a little different for me. This one we are talking about using Fusion360 to create and then 3D print a snap fit pivot. And for those of you who are following most of my videos, you're like, what in the world are you talking about? But I think this is an important one to learn because I've been learning a lot about Fusion360 lately. I've been printing a lot of things with my 3D printer. I've really enjoyed printing those things with my 3D printer that I've designed myself. And this is something that I hadn't quite been able to figure out. So let me show you a little bit of background with regards to where this all came from. So I have been enjoying the Star Wars Rebels series. Just recently got Disney Plus. Really enjoying the Star Wars Rebels series, and in there they talk about this Sith holocron, and I really like it. It just looks really awesome, and I know that there's lots of places online that I can buy them, and I know there's places that I can just find prints for them. But that's not what I want. I wanted to actually make one. So I started looking through some of these pictures here that are available online, and I in order to come up with a design for this, and I noticed something interesting was the fact that these corners, so here we go, these corners, if you look down at them, these guys down here are actually designed to pivot. So while I could design the whole thing as one unit, these corners down here actually pivot on their own, and therefore if I wanted to design one of these and then print it out myself, I would have to somehow make that corner pivot. Now, I remembered back when I was a kid and I was playing with G.I. Joe characters and other action figures I can get my hands on. Those arms popped right off, but then you could pop them back in. And so I realized that there was some sort of a joint that I could use to just kind of pop these things together and then allow them to pivot or roll around on an angle. So I knew that there was some way I could print out this corner as a separate unit, snap it into the main unit, and then still allow that to turn. Well, a little bit of Googling, and one, I didn't find any references to doing this in Fusion360 and then 3D printing it. Hence the purpose of this video. Not just for you to learn, but for me to have for posterity. But so I started doing some research, and I found some action figure pivot joints, and particularly I like this right here, this anatomy of an action figure. And so if I open up this picture and get a little bit closer, this guy right here, the pivot joint, is really what we're looking for here. So we have something on the inside, and then kind of a pivot goes in and it kind of clamps in. You can kind of see a picture of it over here as well. So that's what I'm looking for, but how do I actually make that in Fusion360? A little bit more searching, and I found some references here. Somebody actually did do a 3D printed pivot joint, and they specifically call it a snap fit pivot. And it looks kind of ugly. Quite honestly, it looks kind of ugly there as far as being a 3D print, but we can kind of see the way I remember it being when I was a kid. There was kind of a ball here with a slice down the middle, and then the ball kind of squeezes together as you start pushing it in, and then the bottom here kind of latches it in to keep it from going back out. And you can see they did that here, where they stacked multiple of these units together in order to, I don't know what they're actually making there, but it actually did latch them together. They're not permanent, they can be pulled out, but then they also rotate fairly freely. And they had a nice diagram of everything that we're looking for here. And let's see, if I click on this, it opens up in a PDF file. It gives me a little bit more information about what I'm doing. So as far as the pivot joint, it looks like this is my goal, is to have some sort of a stack that comes up, has not quite a ball. It looks more of a hexagon almost, within a slice down the middle. the receiving end is over here, and the math, the numbers here really help me out as I'm planning this, because I realize, like for instance, the bottom here, the thickness down here, it says is 0.24. Now I'm going to be making this more than 0.24 millimeters. I'm not sure what 0.24 inches, I don't know what that means, but they say it's 2.4 for the diameter here. But the diameter over here is closer to 2.74. So this tells me that I need my hole to be bigger, the receiving hole to be bigger than the maximum diameter here, yet still needs to be smaller than the diameter of the ball on top, which is 2.8. Somewhere in between. So this diagram gave me lots of help, and so let's see how we could do this ourselves in Fusion 360. Now, like I said, I'm trying to do a holocron, so I'm going to start off with just the corner. Actually, first thing, I'm actually going to create 2 assemblies. So, new components. I'll create the first one here. I'll call it holocron corner. And then I'll create another component here that I'll call test receiver. I before E except after C. Oh, I didn't want that to be part of the holocron corner. There we go. So the holocron corner is what I'm going to design first, and then I'm going to let's see. So I'm going to design this portion right here first. That actually has, the corner of the holocron. I won't decorate it like I plan on eventually doing, but I will do this part right here. And then as a test, I will design this part right here just to be able to print out very quickly, see if they snap together properly. All right, so we'll start off with the holocron corner. Before I get into that too much, I really enjoy the fact that I can have parameters here. So I'm going to start off with some parameters and put in my sizes. These user parameters are really great. They allow you to just set things up and then not worry about them later. Everything we're working here is going to be part of a corner, so I'm going to call this corner side. How long do I want each side to be? I'm going to say 25 millimeters. Remember, this is kind of a pyramid shape, so that means any one side, any one corner or length edge is going to be 25 millimeters in length. Since it's going to be a corner, not just a triangle, I also need a height, which is not just the sides, but the heights. And we do that by, let's see, corner height. And we do this with a little math. We figure out the corner side times the square root of 3 divided by 2. If you're not super familiar with trigonometry, don't worry, just take my word for it. Just Google how to figure out the height of a pyramid, and that's what that actually is. Let's see, so that gets me the sides, that gets me the height for my pyramid. I'm also going to need some items for my pivot. So I'm going to call a pivot inner. I'll say that's 4 millimeters, a pivot outer, which I'll say is 5 millimeters, and then a pivot gap, which is 1 millimeter. So for the post, the bottom of the post, see the bottom of the post right here, that diameter is going to be my pivot inner. The outside, or the larger post here, right here, will be my pivot outer. And then the gap will be the size of this slot down the middle. All right, so with that said, let's go ahead and let's create our very first sketch. XY, let's go ahead and create a polygon. Circumscribed, inscribed, I don't think it really matters. Really what it does is just allows me to start from 0. And for the size here, I'm actually going to leave the size blank. I'm going to leave it to whatever, and then I'm going to say 3 sides. There we go. All right, so I've got my triangle. Hit D for the dimension, And I want to dimension that right there, and that is going to be my corner side. And there we go. So we went ahead and we just redimensioned the whole triangle. Everything is now 25. It looks like it's slightly off. So let's straighten it out just a little bit. There we go. I think that's, excuse me. Yep, that looks straight. All right, so much for that. That one is great. Now what we want to do is we want to create an offset plane. So this is the bottom of our pyramid. Now we need to create the top. For that, I will go ahead and construct offset plane. Where do we want to start? Well, we want to start right there. How high do we want that to be? That's going to be the corner height. And so that creates for us the offset plane. At that point, I want to do a sketch on this offset plane. Really short sketch. What I'm going to do is I'm just going to add in a point. So create point. I'm going to put it right here in the middle. There we go. Finish. And what we do at this point is we just say we want to create a loft. So a loft between that point and our triangle. And right like that, we have a pyramid. Just got to look at it. Something doesn't look quite right. Something's wrong there. Oh, maybe that's right. Okay, we'll call it for good for now. No, something doesn't look right. Corner height 2165. Oh, I know what it was. Okay, hold on. Let's undo that loft. Let's go back to our sketch. Edit sketch. What we want to do, actually, let's delete that sketch. All right. Make our prior sketch visible. Okay. I realized what I just did. I want to, create a new sketch. We want to create that on our lofted. Try that one more time. Oh, there we go. Okay, so create a sketch. Wait. You can obviously tell I am not an expert at this. So let's try that one more time. Offset plane. Off of, sure, we'll go off the bottom this time. Corner height. There we go. New sketch. Right there. That's looking better. Okay. Just to be absolutely certain, I'm going to go ahead and project. So hit P for project, and I'm going to project these sides in. And okay. I'm going to create a couple of new construction lines. So I hit L, I'm going to select construction. I want to go from this corner up to the midpoint there. This corner to the midpoint, and sure, why not? From that corner to the midpoint. Okay, right there in the middle. That is my center. That's looking a whole lot better. So now create point. I want to create a point right there. Now we'll finish the sketch. Now we will create the loft from that point to that. And okay. And that is looking like a more appropriately sized pyramid. All right, three-sided pyramid. Perfect. All right, so now if we look back at the rebels here, basically it's a three-sided pyramid. Four-sided pyramid. This side back here, and the side underneath, they're all going to look exactly the same. So I'm not going to worry about decorating those. This inside right here, that's going inside of the rest of the holocron, is what's needs to change. So I'm going to go ahead and we'll just pick a side. We'll say that's the inside, and we'll start working on that. Let's see, since this side is the front, I will go ahead and choose the front. So what I want to do is on the front, I want to create a new sketch. So new sketch, and I want it to be on this plane right here. So I'll go ahead and select that. And same as what I just did when I created the offset plane, I want to find the center of this circle, because when it pivots, I want it to pivot off the center. So I'm going to go ahead and hit L for new line. Come over here and click. No, sorry, not L. I want, yeah, L. I was thinking maybe I needed to project through, but no, this is my lines right here, so I don't think I need to project yet. So new line, construction, start down at the corner, come across, find the middle right there when I see the triangle. Same thing over here. Hit the triangle, and just for good measure, I'll do the top one as well. That one's a little bit more obvious since it already had the green line in the back. All right, so right there is my center. What I want to do now is I want to create a circle. Yeah, one circle. So C for circle. I look at my options over here. I want the center diameter circle, and I want to start right there at my center, and I'll pull it on out. Now, it doesn't necessarily matter what size I type or what I have in here. I'm just going to type pivot inner. There we go. And so that sets the size right there. So that's my inner pivot. That is this guy right here. So that's this bottom diameter. And so what I'm going to do now is I'm going to push that up, and then I'll create the top one. So let's go ahead and finish that sketch, and let's extrude that out. Now I want that to be out, probably about well, let's just choose a random amount right now. There is actually a distance that I want, and it has to do with the thickness of the plastic I want to print. Actually, before I extrude, let's shell this out. So to modify and shell, I don't want this to be a solid triangle. So I'm going to go ahead and select all the sides, including the bottom. And I'm going to say I want this to be 2 millimeters in thickness. So what that means is if I come up here and right now it's hollow. It's a hollow triangle. So if I come up into inspect and I say section analysis, this will help slice through. And I can see right there, everything is 2 millimeters in thickness. Okay, cancel that. Now I'll go ahead and I'll do that extrude. So if everything's going to be 2 millimeters in thickness, that means ultimately, see, about right there down to there needs to be about 2 millimeters. And you can kind of see that right here. The overall thickness of the plastic is 0.25, and then you look right here, they have 0.25 going up to the bottom of that cut, or that chamfer right there. But we'll worry about that in a minute. We'll come back and we'll fix that dimension afterwards. All right, so that's the inner diameter. Now I want to create an outer diameter. This is really easy because what I can do is I can just go ahead and do a new drawing, and I can stack it right on this edge right here. So new sketch. I'll select that face right there. This time I want to see, it looks like I still have my center point. So I'll do C for another circle. Come to the center. Oh, it doesn't seem to be projecting that through. Let's go ahead and hit P for project. Click the triangle. Does that? And then, okay. There's our center. Okay, so center circle right there. And this is going to be pivot. Pivot outer. All right, and then we're finished with that sketch. Let's go ahead and do another extrude. Now we'll choose that and the inside there. We'll pull that out and we'll just leave it at something. We'll fix the length here in a second. Looks like a nice little tank for right now though. All right, so now being a little bit more specific, let's look at our diagram here. Where's my zoom? There we go. So we can see right here that we have chamfers on both sides here. The lower side, it tells me that this is 0.02 something at 45 degrees. I'm going to assume that that just means I pretty much want a 45-degree angle from there to there. So from the outer post to the inner post, or outer pivot to the inner pivot, a 45-degree cut. It doesn't really matter how long that is, as long as it's exactly 45 degrees. The top side, however, it says 0.040 at 45 degrees. So it's still a 45-degree cut, but you can see right here that line ends up inside. So there's more of an angle on the outside than there is on the inside. Which kind of makes sense because when you're assembling it, you want it to snap together, but then be harder to come apart. So you want it to be easier for it to go in and then harder for it to come out. So let's work on those chamfers. So I'm going to come up here to modify and chamfer, and I'm going to select this inside circle. I'm sorry, the out, excuse me. This edge right here, so not the inside edge, but that edge of the outer diameter. And I want to slide that in. It looks like 0.05 is the right answer. If I try to go any further, it starts yelling at me that I've gone too far, that I'm trying to cut out of this pipe right here. Yeah, 0.04, I can still see that there's a gap. So it looks like 0.05 is the answer. So I'll take that. So then let's go ahead and do the same thing on the other side. So modify chamfer, choose the outside. Now if we did 0.05 on the bottom, I want to do something more than that. I'm going to actually maybe 0.1. Let's see what that looks like. That doesn't look too bad. We may actually need to, we may have to change that in the future, but that's easy to do. So let's go ahead and leave that. So at this point, let's go ahead and figure out how long this barrel should be, or this post should be, and then how big this post should be. So if the overall if the overall thickness of everything is 2 millimeters, and let's see, this guy, they said 0.23 for that portion right there, from there to the bottom, as opposed to 0.25. So it's not the full height. So we want this to be a little bit less than the full distance or thickness of the material. If the full thickness of the material is 2 millimeters, we want this to be a little bit less. Maybe 1.5, 1.2, 1.25, maybe. I think 1.25 probably. So let's come back here. Let's go back to our extrude history. That's that guy. Let's edit that feature. Let's put this to 1.25 millimeters. And that nicely slid everything back on in. All right. We then look at this again here. So if that was to that point right there, of 0.23, it then goes up to 0.35 for total. So it looks like a little over one more. So let's go ahead and make this guy. Let's move the second extrude. Let's see, it's currently at 6. Let's try 2. That looks pretty good. If I go any closer, that may cut off. Let's try it. Maybe 1.5. That may work, but you know, the diagram here shows a flat spot. And if I go with 1.5, there's no flat spot there, so I'm going to change that back to 2. Yeah. All right, so assuming that that's okay, now we just need to add it in the cut. We could have done this before, but then that would have complicated things a little bit. But what we need to do is come back here, and we need to slice our inner circle as well as our outer circle. So we'll go back to our sketches, our original sketch. Let's go ahead and edit that guy. And what we want to do is we want to just draw a rectangle right here in the middle. So I'll hit R for rectangle. For the type of rectangle, I'm going to choose a center because, hey, I want you to start at the center. Let's go ahead and look at our sizes here. Let's see. I want the thickness to be 1 millimeter. So that's going to be, I think I called it pivot gap. There we go. And then as far as the height, what was that? Pivot inner? There we go. And yes. So now if I finish my sketch and I modify that extrude, right there, I should be able to choose which profiles I want, and I can unselect the one in the middle. Yeah, look at that. So now it's just slicing the two sides and it's leaving the middle out. I really love this parametric designer. The fact that you can go back and just change the numbers and everything updates automatically. All right, now let's do the same thing for the second one. Ooh, hey, that's nice. Gives me a little warning because there's a hole there. So let's go ahead and edit that one. Let's do the same thing. R for rectangle. Make sure it's a center rectangle. Start off at the center. Let's see. That was pivot outer because we're now working on the outer side, and pivot gap. That doesn't look right. Pivot outer, pivot gap. There we go. Finish sketch. Let's update that extrude to remove the inner piece. And okay. And now we've got it. All right, so that is almost everything that we need there. In fact, at that point, we are pretty much working. So let's hold on to that as it is. And now let's go over to our other side, our test test. That was all in the test receiver. All right, so we just modified the wrong thing. Let's actually... Let's just go ahead and rename this guy. I hate it when I start working on something and I find out all the way when I'm done, oh, I was in the wrong place. All right, so that was the holocron corner, and zoom out, and yep, that looks pretty good. We should be able to snap that into something as long as our 3D printer accepts it. So let's go ahead and start working on the receiver. For that, I'll go ahead and hide. No, I don't want to hide the core. Yeah, I want to keep that up there. Okay, so what I want to do is I want to create the receiver. And I think I want to create it on this plane right here so I can have everything built together in one place. So let's see, if I create a new sketch, I want to create it on that plane right there. Yeah. And I don't know if I need to project. No, I shouldn't need to project that through. I do want to find the center. So again, same thing, a line. Let's make it a construction line. Down at the beginning, all the way up to the middle, right there. Another line to the middle, and from there to the middle. There we go. And now I just want to create my receiver, and I want to create it really simple. So I'm just going to create a circle, just a center circle, starting right there. And let's just create this. That'll work. Really, I just want something. Oops, I didn't want that to be construction. Just want something simple that I can plug in. I will eventually extrude this out to 2 millimeters. But for now, that's good. All right, so I now have my receiver portion. Now I need to create a hole here in the middle, and then I need to chamfer the angles. So let's go ahead and create the corner. So circle, create a circle right here in the middle. Oops, circle from the middle. And I'll just, why is it construction again? There we go. And I'll hit D for dimension, and we'll pull this dimension out. Now this dimension should be something with relation to our pivots on the other side. So this is going to be somewhere between the pivot inner and the pivot outer. So let's say it is, well, pivot inner plus maybe halfway between inner and outer. So pivot outer plus pivot inner. So it should be like 4.5. That's not right. Minus, not plus, minus 5. Came out to exactly 5. Pivot inner, which would be 4, plus the difference between the outer and the inner. So 5 minus 4 would be 1. Oh, divided by 2. That's what I want. I want half of that. So it should be 4.5. Now I'm really just guessing right here. As you can see, they're saying that that's 2.74 as opposed to the 2.4 and the 2.8. So we might want to range a little bit closer to the larger end. In fact, I recently just saw a video the other day. 3D printers seem to have problems with the inside diameter of holes. So I'm actually going to bring this guy up. I'm just going to say pivot outer. The inside diameter of holes, I'm told 3D printers make a little bit smaller than they should be. So we'll just print it out at 5, and we can shrink it down. We can start minusing from there if we need to. Okay, so I think we are done with our sketch. Let's go ahead and close that. And then let's extrude this guy. Interesting. Hold on, cancel that. We don't want the triangle. Let's get rid of the corner. There we go. Extrude. Still wants to do the corner. Do the triangle. Not a problem. We want this to be 2 millimeters. All right, so now we've got our test receiver. Let me go ahead and add in, let me change the appearance here really quick. Yeah, let's just make that red. No, the whole thing red. There we go. Just so we can see that the two different things are different items. All right, so now we need to just chamfer those inside corners. Looks like it's just a 45 degree. Let's see, they're saying 0.25 at 45 degrees. So we did a 0.02, and now they want 0.025. So if our 0.02 at 45 degrees was 0.5 millimeters, they're wanting, let's see, if we made this side 0.5 and 0.5, and then we made this one 1, this would be 0.6. Sure. And that would be on both sides of that. So we should be able to come up here and chamfer. Let's select that end as well as that. And then I think we just said 0.6 millimeters. Sure, we'll call that good. And now if we bring the corner in here and we make the whole thing visible, we should now have a fully functioning, fully pivoting design that allows each side of this to spin independently. Well, we'll see how that works. Actually, I'm kind of curious. Let's inspect. Let's do a section analysis. We'll choose off of this side. There we go. So we can see that there is, in fact, a gap between all of those, but not a gap between those. So that should be pretty good. I'm wondering if maybe our outer diameter here is too far away from the main body. Really, I think I may just have to print a couple of them to see how that comes out. All right, cancel that. All right, so we're almost done. There is one last item I want to put in here, which kind of comes back to our original design. And for this, there are quite a few options or quite a few examples of them. These guys, like I said, all three outside edges are all going to look exactly the same, but they should line up in one direction or another. Meaning they should be in this angle, or if I turn it 66 degrees, it should lock again into that place. So I want to have some sort of a locking mechanism. Now this is new to me, so don't take my word for it, but I should be able to put some sort of a some sort of a sphere or set of spheres onto this plane right here, and then have the same have the opposite on the receiving side, and they should essentially lock into place. So let's go ahead and try that. So what I want to do is I want to do something on this side. I want to create a sphere, and how would I do that? Let's see, create sphere. I want it to be on that plane. I want it to be halfway up. Doesn't exactly have to be halfway up, just has to be somewhere in there. Sure, we'll put it right there. 1 millimeter seems good. I don't want it to cut. I want it to join. There we go. So now I have a little nub sticking out. In theory, if I remove that same nub from the other side, from the receiver, it should be perfect. So what I want is I want 3 of these. I want one there, and then one there. I want them all to be the same distance away, so I need some sort of a circular pattern tool, which I need an axis to work. Okay, so let's set up an axis. Let's see. For that, I'm going to create a midplane between that end. Between that plane and that plane, it sets up a midplane right there. Perfect. Should work. Try a sketch onto that plane that we just created. And what I want is I want a line, this time a construction line, from there up through there, right through the middle of my nub. All right, finish sketch. And so now let's see how this works. Create pattern, circular pattern. I want features, and I want to select the sphere I just created. The axis, I want to select the axis or the line I just created. And quantity of 3, and I can see it's placing them right there perfectly. Not sure what compute option is. Okay. Ooh, almost. All right, so I can see this one's perfect. It's right intersecting the plane. This one, no, they are sticking too far out. So I need to modify that. So let's see, there were a couple of the other options there. Optimized? No, that doesn't seem to do it. Nope. So let's put that back to adjust. And looks like I might have to edit my sketch. So this is where I'm not entirely sure. I'm going to remove my constraint. And I don't know about there. Looks better. It looks like I went too far up. Okay. Edit that one more time. That's about right. All right, so that looks about like that one is about as far out as that one. So it looks like they're centered. This is probably the one area I'm not super familiar with, so we'll see how it works out. All right, so with that being said, now we need to do receiving nubs into the receiver. Turns out that one's actually really easy. What I want to do first is I want to take this dimension right here and I want to extend it out. I want to make sure that these guys are not in the way. So let's find that extrude. That was this guy. See, we're currently at 1.25. Let's just go ahead and set it at 5. We'll remember that it's 1.25. We'll then come back up to the main body, or the full main project. Where's my receiver? There we go. All right, so I want to use the combine option. So target body is this guy right here. The tool body is this, and the operation is cut, which means anywhere that the the target body is intersected by the tool body, there will be a cut operation. It will be deleted or subtracted from the target body. Keep tools is selected because I want to keep this guy right here. Obviously, that's the thing I've been working on all this time. So I say okay. And now, just as an example, let's hide the holocron corner. Let's look at the target, and I can see I now have nubs in there, little receiving nubs that identically matched what were in the holocron. All right, so back to the holocron. One last thing. We extended that post out. Now we need to shrink it back down. Let's go back to our extrude, edit, 1.25. And there we have it. So in theory, that should, when I print that out, not only should the holocron corner itself snap into this receiver that I just created as a test example, but when it does, these little nubs should hopefully latch it into place and allow it to not only just spin, but also lock it into a certain location when it's done. So that is my first run at how to actually create a 3D printed snap fit pivot. I did a couple of examples, and this is pretty darn close. Sorry, I've printed a couple of examples, and this is pretty darn close to actually working. Like I said, this is my first time working with these little nubs here to help do a snap fit or to lock it into location. I'm hoping it works. If not, I'm pretty sure this is the right way to do it. It's just a matter of working to the right answer. All right, I hope this has been helpful for you, and have a good day.